Okay, concentration. Good. So, good morning, everyone. I'm very happy to see you. And today we're going to talk about Stable Diffusion as an idea, basically. And we're going to talk about how we implementing it and how we operating on the Stable Diffusion models in one of the UIs that existing in this world. Okay. So first, before we'll jump to what was the point, like what I want to get from this workshop. After this workshop, I want that people will have basic understanding how the machine learning models do work, and specifically how Stable Diffusion models are working. And then you will be able to implement your knowledge in any UI. I did choose ComfyUI, which is just, envelope, because you very clearly can see how model, Julius?
Sorry, just very quick question. Do you want to record?
I did already. I'm recording. Thank
You
you very
did.
much.
Okay, sorry. Okay, thank
Yeah.
you.
Yeah, thanks, man. I did choose ComfyUI just because after I watched few of the UIs, I saw that they a little bit opaque with what's happening inside, and ComfyUI is not based, and that's why we'll be able just to follow really the process that I will explain in beginning, and it will be not just some white paper that you're reading and you're like, oh my God, I'm so stupid and will never learn it, I don't know what to do, but you will be able to actually see, read, understand, implement. We're not going to touch anything which is complicated. We're not going to go deep inside of the process. We will be able to sit inside of the car and drive. And how long I doing this? Like let's say 2 years, we're dealing with some kind of machine learning stuff. Okay, and with ComfyUI, I just sat down 1 month ago because I wanted to put my hands actually to business. So I don't have very deep understanding. And what I really would like to do is that you will just be not afraid to go inside and start moving stuff. Okay, so hope not too very long introduction. Let's go to the very first page. Okay, so how does the Stable Diffusion works in very simple way, explained or like basically in very basic stuff. And if you will have a look on this GIF on the right side, we have a drop of ink which is going inside of the water. Okay, and when it's going inside of the water, it's completely diffused. Okay, we're very used to see the process. We completely not used to see the process which is going backwards, meaning that if we would be able to calculate how the diffused drop will come back from being diffused to the way it was in very beginning. And that's exactly how Stable Diffusion models are working, how they're saving information, and also how they do bring back information. So right now it's like, okay, Alexey, let's look in more kind of like in the details into it. So of course, to calculate something which is inside of water is really complicated. You need very big computational power. So they did simplify it a little bit to certain extent, and instead of the water, they're using noise. And let's see what is happening. I will go from backward actually, from here, from the 4. Let's say we want to save this cat picture inside of the model, okay? And what's happening in Stable Diffusion, we're starting to apply layers of noise, one layer, and let's call it steps, okay? We're applying noise, we're applying more noise, we're applying more noise, we're applying more noise. In the end, exactly as a cup of water, it looks like nothing like a cat. But there's a very important thing that machine learning model remembers how noise was applied, what seed of the noise that was applied on this image, and you can reverse engineer that, meaning that later if you will take the same image, which for us humans looks like nothing but noise, and if you will start to subtract the same pattern that you apply to this image, in the end you will come back to the cat. Okay, so you will have picture of the cat, and as you can see, nothing like that, exactly the picture of the cat. And it still does not make sense for us. Well, okay, Alexey, congratulations, you can store it in a very weird way. We don't know why, and I don't know why. It's actually rocket science, and it's actually very complicated how it's done. And then we can come back and have our cut back. Great. But now let's add the complexity. We're not storing one cut, but we're storing hundreds, thousands, and maybe millions pictures of cats inside. But let's store just picture of the cat and picture of a dog in the same way. So there will be another picture of the dog, and then we'll diffuse them together, and then there will be some noise which will inside of it have a cat and a dog. And now when we will come back, we'll not get cat or dog, we'll get some mix of that, which will be very weird for us, right? We're just like, well, what is that? We don't need it, we don't understand that. What is this picture? And here coming inside another very important part, which called clip, or let's say conditions. Every model will be able to communicate with us, or more, we will be able to communicate with this model. So when model was created, when model was kind of like training, it received a lot of pictures, and in our case right now, it's just picture of cat and picture of dog, very simple. But additionally, it received also text, and it was so-called tokenized, meaning the text became token. Every letter is a token, every word is a token, a few words together is a token, meaning it's how we're talking to machine. A little bit confusing, we'll get there very, very fast. So when picture of cat was shown, it was written a cat, or it was written cat looking into the camera with the stripes, green eyes, blah, 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 so with explanations. So whenever it's saved in very weird way that we don't understand, but machine also saved these tokens, saved this information, which is just text. And whenever we want to bring back from the noise our data to the picture, we can tell machine what actually we want to extract. For example, if we will just write in our prompt a cat, he will go to the noise, and then whenever he will come back, he will start to pull it to direction of a cat. He will not react to some details which are saved as details of dog, and he will bring it towards direction of the cat in very simple way. If we will write cat looking into the camera, he will check in all the pictures that he has from the cats, and he will try to bring details of cat which is looking into the camera. And he will do it in certain amount of steps till machine will say, well, you know what, I converged, or maybe I didn't converge. And this is the steps that we're talking about. It's very important. Few stuff that few terms that I'm mentioning. It's the steps. It's how many times we applied the noise, and then how many times we reduce the noise. And then also, which is important, is prompt and clip. It's how we're pulling this to certain direction. Now imagine you have millions of pictures, which you will have, and every model that you see, like on LinkedIn, we have 8 billion tokens, we have 15 billion tokens. ChatGPT, we have 80 billion tokens. The more tokens your model will have, the more parameters. It's different things, but let's say the easier for you to talk to this model, the more this model is understanding you, because it has better understanding of what you're writing in your prompt. Okay, so our models, they are not 2 pictures, they are billions of pictures or millions of pictures and billions of tokens, which are explaining what's happening inside. So far, I believe we are okay. Raise your hand if you feel like, many of you like just getting lost, but so far we're noising, we're saving this in certain way, and then we bring it back. Now, next thing which is happening that we when we turned all this inside of noise, that's how it stores in the model, and we want to bring it back, we always will apply certain noise additionally to that to give us very basic variance. You remember with the prompt, we're pulling to the certain direction, but if our noise is always the same as it's saved, it will give us what we want, but there will be not much variance in the details that it's going to give us. And that's why in the end, we're applying some random noise on top of that, so all the information that's stored will be slightly mixed. And that's where seed is coming in play, that you can alter your seed when you're applying on top of all your noise. And then when stuff will come back, it will come back slightly different every time. And this is the random nature of generative art. That's where kind of like a lot of stuff that we see that like, well, it's hard to get it because it's like, well, you're changing the seed and picture can change completely or not completely or a little bit. So we learned already a few things, okay? So we learned steps of the noise that we're applying. We learned that there are different seeds. And next thing that I would like to touch is latent space. Not very critically, crazily important, but good to know. Okay, so images in most of Stable Diffusion models are saved not as a red, green, blue image, but they saved in latent space, meaning we cannot visually see the picture when it's saved in latent space. So this cut in the latent space will look different. Why is it happening? Just because of compression. If I'm not mistaken, latent space is 48 times smaller than normal picture that we see, and that's why it is way more efficient for machine to go to this space, do all the calculations, and then get back. The process of going inside of this space or coming back is always very well defined inside of the model, and it's called VAE, which is variable autoencoder. Don't try to remember basically variable autoencoder. I don't remember. Just remember VAE will be responsible, each model will have it, will be responsible to take the input picture and with a certain rule convert it to the latent space, to encode it, and then to decode it back. So we learned now, additionally, we learned VAE. We almost done. I know that right now it's all kind of like, wow, Alexey, you're throwing a lot of terms, or not so many actually, something like 5, but don't worry, we will get there. And I think right now I will stop with these terms because better now we will go and actually look into it inside of the application. And then we will repeat, I will repeat myself. I will add additional terms and additional conditions. We will talk that will be very important. But right now, I think it's too much of the dry information. Important in these slides that I'm presenting right now, there are a lot of links. The first one, how the Stable Diffusion works. It's really amazing page. I really recommend it to read. And here, there's more technical pages about the VAE, latent space, different samplers. I will get to samplers as well, conditions and tokens. Okay, so next one is what will be our application. It will be ComfyUI. There are also very popular automatic 1111, Invoke AI, Easy Diffusion, and so on and so on and so on. Okay, so you can check each one of them. You can click on the link, download, install it at home if you want, play with that. I'm using a lot site called Civit AI for resources, and there is a vibrant community with a lot of additional models. I will talk about the models in a bit, and a lot of examples that you can just drag, drop, and see how it was built. For Trickstarians, guys, to start ComfyUI, you just need to run it from this directory. And regarding folder structure, so right now, yes. Okay, good. A little kind of like technical thing. When you install a ComfyUI, it will basically create this location, and then you will have to install a lot of custom nodes. You will see very fast, immediately, in the first minutes, you will try to implement workflows, and you will have to install custom stuff. It's very easy to do it at home, because you can just go to the manager and install it. I will skip any explanation on installation right now. It is major pain still. It's easy, but sometimes it's not working. But you will have to deal with the directory quite a lot when you're doing by yourself. Okay. A little bit about UI, and this is kind of warning. When you downloading workflows from internet, you will see something like that, and this is not a bad one. Don't be intimidated, especially after this workshop. Hopefully, just always, you have experience. I'm talking to compositors right now. You have experience with the node-based compositing, node-based work. Most of these people don't. And they're building something which they think that looks amazing. It's completely not readable. By the end of the day, all these workflows are junior level workflows for compositing. Really, there's way less stuff happening. It's just very complicated because people don't know how to build node graphs. So when you see something like that, calm down, go inside, spread it from left to right, and you will see how easy it to operate that. So this is kind of like very first thing. Okay, here is just for you, if whoever will want to follow this guide, is little shortcuts for later, how you operating actually node graph. And let's jump to first thing that we would like to do. And we will try to do text to image workflow. This is very basic workflow, and we already basically this set up the scene for that in beginning with all the terms. We know that we have a model. We know that we need to give this model some text, and then we will want to have some image. Okay, and this will be our first workflow that we will dive into, and this will be approximately the first image that we will get from our Comfy. We will have our checkpoint. What is the checkpoint? I hope you can see actually what I'm showing. I will zoom in later, but I first want to give you an overview of everything that I told you previously, but already inside of the node graph. We will have to load the checkpoint, and checkpoint is our model. I did really glazed above the models, about the Stable Diffusion models, but right now let's talk about a little bit more in depth. There are two models existing right now for Stable Diffusion. Okay, I'm ignoring Stable Cascade for now. Two models. One of them was created a few years back, and it's Stable Diffusion 1.5. And this model was trained on images which are 512 size. Small ones, okay? And size of this model is quite big. I don't remember the number, but we will consider this model, the first one, the small model. And now the second one is SDXL, extra large, which is existing probably 6 months. This model is a newer model. It is bigger. It has same architecture, but is bigger, and it was trained on images which are 1024 by 1024. Additionally, this model bigger not just by image size, but by amount of tokens. Remember ChatGPT 3, ChatGPT 4, and that will be the difference. It is very easy with a SDXL model to create something which is looking very, very cool and very, very fast. Okay, so this is our model. Whenever you're loading model, you're loading checkpoint. Okay, and here I'm loading SDXL model. Next one will be our prompts. We will make one prompt condition, positive condition, which means we will decide, we'll say what we want, and we will make one negative condition, what we don't want, which is also very important. We don't want ugly picture, like, you know, it's really like kindergarten with this, we don't want. We don't want this foggy, we don't want this ugly, and so on and so on. And then we will go into the heart of computation, which called KSampler. I will explain KSampler really in depth in a bit. Then we will get out of it, and here we can see VAE decode, it meaning we're going out of our latent space. By the way, latent space, I missed something. KSampler is working in latent space, and since we are not giving him any picture, so we need to tell him at least what will be the size of the image that we're working with, and this what this node is doing, empty latent image. 1024, 10 by 1024, going inside. This is our read node, our black constant. Okay, very simple. We're going inside of KSampler, then we're going out of KSampler with our latent space after we did the computation, and then the thing of VAE, converting latent space to red, green, blue space. Now let's just have a look one by one on our checkpoints, and just to see that we're not missing something. So that's how checkpoint looks like. Checkpoint will spit out a model with all the data. It will spit out clip. Clip is the area when we will create our conditions, and there will be prompts, there will be control nets, there will be IP processor, there will be whatever different conditions we will add, but that's where we will operate on them. It's like how we're pulling model to certain direction. And also he will tell us with VAE how we will go inside of latent space and outside of latent space. Okay, so that was our first node, load checkpoint. Now the second one that I want to talk about is a KSampler, and this is the most important one, I believe, in basically in computation, because that's where magic is happening, and that's where I very hope right now we will start seeing things which are familiar to us. So first of all, what he's expecting. He's expecting the data of the model. Okay, what we are working with. We're working with this model. Great, thank you very much. He will expect to which direction we want to pull it. Positive condition. To which direction we don't want to pull it. Negative condition. And what will be the canvas? What will be the read that will enter this sampler? And here, very important parts. So, you remember the noise that I mentioned that will be added before we denoising? This is the seed of this noise. And as you can see, there's like, you have a huge amount of the seed that you can apply. You can apply it in random way, in fixed way. We will see what we're doing there later. The next one will be the steps. So what steps will tell us? Steps, it's how many times we want to denoise our noise till we will say, well, we're happy with this result. Basically, your goal as an artist or as an operator is to give him amount of steps that you will deem as a good amount of steps to get nice picture. It's not always that you will give 100 steps that picture will become better and better. Sometimes 5 steps will be enough. Usually between 12 to 30 or 50 steps will be good amount, and you will learn it while you're working. You can easily overshoot. If you give more and more steps, model will try to extract more and more details, and will like, well, I will pull something for you, and you can overdo it, and it's heavy, and you're not getting good result. Steps are extremely important. What is CFG? And CFG is, give me a second, seed, negative, where did I write it? Because I'm forgetting. Yes, someone.
Me. Can you change these conditions on the go, or you need to set it at first and that's it?
You absolutely can change it on the go. You absolutely can change the conditions on the go. You can say, I want this, I want that, and then you're executing. Okay?
Thank you.
Then CFG, guys, I forgot what is the translation. Control for noise.
I think it's like control for noise.
Yeah, no. I want the real one. Like you will find it. Anyway, don't remember that. Okay, what you can remember, it's CFG, and what? Classifier free guidance. Thank you very much. Extremely easy to remember. Now, forget the name. Now, CFG is extremely important, and let me try to explain why. CFG, it's how much you want to bend the model to your rule. And let's just imagine that your model trained a certain amount of material. It knows certain amount of pictures. And if you will put CFG on 10, which is crazily high, model will try to produce exactly what you mentioned in a positive prompt, and not to produce exactly what you mentioned negative prompt. And if you're pushing it more and more on certain model will be not able to produce it for you. So you for example, you want to say that I want a person wearing glasses, standing on one leg, one hand is here, this is here, and I really want it like that. And model will try to bring it for you, but it will break, because in a certain moment it will like, I will just invent something for you because I don't have it in my data. And something that I was talking to a friend yesterday, and we kind of arrived to a conclusion. It's like a director is talking to an artist, an actor, and saying, well, I want that you will be more in love. And the actor is giving you like, oh, I love you so much. No, give me more. And then after a while, actor is like breaking. It's like, dude, I cannot be more in love. That's my maximum. So you don't want to push it too far, your control. From other side, if you will go to very low values, you give freedom to your actor. You're saying, dude, give me some love. And then every actor will give you love differently, and that will be a little bit crazy maybe, and will be already not PG-13. So you don't want to give your model too much freedom, because it will give you a result which it's unwanted. Usual values of CFG is between 3 and 8. Okay, you very fast will find out that, well, okay, that's kind of like, that's where I want to be. With the different models, with different LoRAs, it can be like even 1.5. But again, that's something which is less important. I mean, it's very important, but basically you will get there. Okay, so that was CFG, extremely important slider. Next one, we have sampler name and scheduler. I will just consider them biyachat. Sorry. I will consider them together, and basically this is how your steps are applied. Imagine you want to denoise your material, and you're going to apply 5% less denoise, 5% less denoise, noise, 5% less noise, 5 less, 5 less. And you want to arrive to convergence. You want to arrive to best picture. You can go 5, 5, 5, 5, 5, 5, and you need like 50 steps till you will be there. Or you're saying, well, I will go the halfway, I will go 50, and then I will go 20, and then I will go 10 and 5. So the difference how your steps are made, they're different sampler name, different samplers. So this is really rocket science, and there are many of them. It is not crazily important for very beginning. You will be very fine with the Euler and normal as a beginner. When you will start to play with this, maybe you will go to this one or that one. There's like this list of them. Right now, I do have my preferences, but again, I by no means I feel that I'm really know what I'm doing there. But you kind of like, you know, you can read about that. Maybe then you will be a little bit more educated. For the different samplers, you need different amount of steps to get to your result. Some samplers will never get to your result. So for example, if you're saying, well, I want 20 steps, it will be like, okay, I want 15 steps. He will be like, this is the sweet point. But 30 steps, it will be completely madness. So it is a little bit, maybe a little bit complicated later, but for now, easy peasy. The last one is denoise. We will leave it on 1, and I will not talk about denoise right now too much, but I will come back in a while, soon. Denoise, it's how much noise with this seed we're applying to the image or canvas that's coming inside of our sampler. Okay, so we are ready, I believe. No, let's talk about the prompts themselves. Okay, prompts, as I mentioned already, we're giving positive prompt, we're giving negative prompt. I also, this is the guide for the prompts. After you will read this guide, you will be the prompt artist. I'm joking a little bit, but frankly, it's on our level right now, it's enough to just write few words and you will get very good result. Now, I do think that prompts are extremely important on the next level, not on our level, because it's the way you're talking to the machine, and not everyone can talk in the way which is very efficient, because there is a science how words, tokens, saved inside of the model. And if you will know which tokens to get out by wording it properly, then you will get your result in more easy way. Again, on our level right now, we'll just type something and we will get something, and that will be good enough. You want to dig into it, there is a really huge amount of information out there. Empty latent image, very easy. We're giving a canvas, and that's the size of our canvas. And VAE decode, we started from decoder, and very beginning, it's how we're getting out of the latent using VAE knowledge to the image. And save image, basically, let's present our image. Okay, so before we will go, actually, I will just very briefly say what this panel is. It's panel of ComfyUI, basically, where you executing your prompt. You have their queue, you have a history, you can save your workflows, you can load them, refresh, and so on. So right now will be not very important. And let's build that, okay? I will start from very beginning. So the first one will say load checkpoint, and how do I load it? And sorry for technicality right now, because for me it is important how UI actually working. Double click will bring you this menu. Yesterday working in Nuke, I was double clicking all the time because I became very familiar with that. And here are checkpoints. Here are models. By the way, checkpoints. I started to explain you about the models, and I mentioned, guys, there are only 2 types of models. SD 1.5 and SDXL. But very important to understand that these models were released by Stability AI, and then community did pick them up and continue to train them. And that's how, if you will go to Hugging Face or Civit AI sites, you will see there are like hundreds of models. You always need to be aware what is the base model for your model. If this SDXL or is SD 1.5, it will be written all the time. So I will grab one of the SDXL models that we did download in order to learn the Comfy, and it's Dream Shaper. And why people pre-training this more? Why people adding more training? You have base model, but then you want to create model that will work better on environments. So you will collect huge amount of photos which are which has also kind of the text explaining what these photos are, and you put it inside, and you're training the model, so model will start learn more and more about the environment. So your model will be able to produce better environment picture. It will not produce better picture of humans, but if you want to produce very nice mountain, it will do it way, way nicer. This Dream Shaper was fed with a lot of material from the sci-fi and so on and so on and so on. Okay, and that's why I'm using this model. Okay, and then we will create our sampler, because that's a KSampler. That's where all the computation will happen, and this is quite easy right now. So okay, model will connect to model, that's fine. You cannot connect directly clip to the negative, because clip is just the rod on top of which one you will put now your prompts. And I don't want to type new one. I saved here my negative prompt and my positive prompt, which I took from one of the random pictures on the internet that I found by Kandu AI. And here he just putting the prompt and all the rest of the values. I was just thinking like, well, I will just, instead of typing, I will just get this prompt here. But I will just create the clip text and code prompt. That's how it will look like. And I will just copy it, but you understand the idea, so I will not copy it. I will just put it here and here, positive and negative. ComfyUI is not very comfortable if you don't know how to deal with the node graph stuff. It's very easily starting to be cluttered. I will not use any plugins right now to unclutter it, so I'll try to be very, very organized. We're coming in with clip conditioning, positive and negative. Okay, so far so good. What else we're missing? We're missing the latent image. Okay, if I'll try to execute it, I'll press Control Enter. He will give me an error. He's meeting latent image. So empty latent image, and I will connect it here. What was it? 1024 by 1024 by 1024. Stay with me. We're getting there. Okay, and then we are ready, but we can't see latent, so we should go from latent space to normal picture, and that's why we have VAE decode. As you can see, you can just drag it, and then he will give you maybe options, or you can double click and type VAE decode. Okay, so this is our samples, and he's expecting VAE because he doesn't know which model is going to give him the VAE, and that's it. That's how it's going to look like. And image, again, save image. Now we are ready to go. Let's press Q prompt. I'm using RTX 3090. That's why it's kind of pretty fast and pretty nice. So, and this is the picture that we're getting just on the very much on the fly and immediately. Okay, now I would like to come back to more working on the KSampler, but right now we are done with the text to image. Now your controls are basically going here or going here. I will operate with all that in a moment when we will start to talk about image to image, because it will be a little bit more fun. But question about text to image generation from your side. Everything is clear? Good.
Just one question.
Mhm.
There are or you think there are a specific way to start in terms of prompting? It's like it's better to start finding a base in prompting first and then start to touch about
Yes.
the samplings and everything and about the model, or
Okay,
the
prompting,
reverse?
there is, so as I mentioned, prompting is actually quite a science. So I would recommend you to go to the link that I left in a presentation, and tac, 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 somewhere, and dun, empty lot, yeah. And then there's a guide which explaining how you prompting. I don't want to go there right now. It's huge. It is huge. So let's not go there. Okay. Yes, very important. No, we'll not go there right now. Okay. Okay, we are done. We produced very similar picture to that. We will play with this quite a lot. Now let's talk about the next step, image to image. Now image to image, it's same as a text to image, okay? But instead of, I will go back to my workflow and I will just copy everything that I have. Control C, Control Shift V, and let's go here. Right now, after all this tedious kind of explanation and like a lot of stuff, oh, Alexey, what is this? You will see that if you try to remember these things, you're starting to play with that. Okay, so text to image. And let's go back text to image. So we provided to our sampler what we want from him. We provided the model, we provided the canvas to paint on top. It was painted with this noise, with this seed. But what if we will provide to this canvas, we will provide to this sampler not the empty latent image, but we'll provide some image. And I will just say save image, and then copy image and Control V. Yeah. So right now what I have in my possession is an image, PNG. And I want to use it as a base for my work, which means I want to exchange the empty latent image to normal image. So first of all, of course, we need to transfer this image to the latent space, and we'll say VAE decode. Okay, I will try to be lucky. No, encode. Okay, good. So it will be VAE encode, or usually I'll just drag it, and he will say, well, you probably want VAE encode. And this VAE encode will go from the red, green, blue space to latent space using VAE of the model. And that's it. We have our latent. And instead of empty latent image, we will feed our sampler with the picture. Okay, so that's exciting. Let's have a look how it will work. I will press Control Enter in order to calculate. Since now let me just go here. Since my seed is set to random, every time he will give random seed, meaning he will every time will want to calculate. I will set it to fixed, so he will not bug me anymore, so he will not calculate it twice. And I will set here my seed of the sampler to fixed as well, because we kind of like you know, we don't want many different pictures right now. And I will press Enter. As you can see, he's loading the checkpoint is loaded, and then he's calculating the sampler. But this time he didn't get black latent space, he did get this this image. Okay, so what we've got quite similar result, okay, because like our prompt is exactly the same, our seed is the same, but trust me, some stuff did change there. Okay, so let's change now. Let's play, and let me just put them next to each other. You know, this guy's supposed to be there. Let me just put here. Let's start playing with the stuff as I promised in the sampler. So first of all, we can change our seed to some different seed. I'm just like going up, and I'll press Enter. So different noise is applied, and as you can see, different noise is applied, and our picture did change. Let's go to very random value of this. So right now he will apply random noise, and we could expect that our picture will change quite a lot. We can also say, well, we can say that we want that it will be a human or whatever we want to be there. But for now, actually, let's say Terminator. Okay, and let's see what it will give me. Again, we have a random seed. Our base is the okay, and now we've got our terminator. Now I'm actually very surprised. Let's just give him just terminator and remove half of the prompt. Because I really don't want to have exactly the same result. Okay, so now we're getting way more terminator and with a different seed. Okay, so I will say fixed seed. We're not interested in seed anymore. We're interested in playing with more values here. You remember I did jump over the denoise. Now, what denoise value is doing for us? Denoise, it's how much noise of this seed will be applied to our picture. If we're applying zero noise, okay, we cannot apply zero noise. Let's go very little. Our picture will change very little because, okay, because what's happening, we're giving to this we're giving to KSampler, we're giving a picture, and then we're asking in a latent space, and then we're asking him we're asking sampler to denoise this picture, which is a latent space. But this picture is very kind of like, we know the algorithm that's going to do it. So he will give us, if we're not adding additional noise, he will give us exactly the same picture. And that's why when our denoise level set to very little one, almost no changes will happen. When it's set to very big one, which is 1, maximum change will happen to our picture. And why we need it. Imagine you have some picture and then you just want to change it a little bit. You can start to nudge it to certain direction. You want to add more details. You want that it will be a little bit more happy in certain way. You want to change maybe some slight stuff, and then you're saying, well, you know what? I like this picture. Let's keep most of them of the picture, and we'll just set denoise to 0.2. So we will stick to that, but I want it to be a little bit more like a terminator. Okay? And that's what we're getting. Okay, so okay, that's too little, 0.4, and I will stop now on 0.4 because I think that's kind of like you getting the point. Okay, more terminator. CFG, okay, let's force it to be more terminator, 15, which is crazy number, and you will see how CFG is going to break our picture if we will push it too far. It didn't break it, 25. I will break it, don't worry. Okay, so you can see that picture starting to be less and less realistic. It's starting to be more and more contrasty. So you don't want to go so, and you will see sometimes you can break it completely. So I will go back to 8, and basically what is important for you to get from image to image is the importance of denoise. It's how much denoise we're applying to our picture in order to change that. Questions about image to image? Yes.
Just one question.
Yeah.
Can you change just a bit of the image instead of like manipulating it
Completely.
in a whole?
Yes, I can. We'll get there. Yes.
Okay, cool. Thank you.
I have just a really simple question.
Yeah.
You say when you're starting the process, you say you just press enter. Does that mean you just press enter somewhere in the interface, or
in order to calculate, I can press Q, or I can press Control Enter, and he will calculate. Just
control? Okay.
Yeah, I mean, I learned it after like 1 week, and I was like, oh man, because I mean, it's very handy. Okay.
Yeah.
Good.
Just one more thing. When you're saving an image, you just go on the image and you save it, and it gets saved to like a default directory,
It's
or
saved in your downloads by default.
Okay.
Yeah. Additionally, every time when you're generating image, it's saved inside of your output folder. So you need to be aware that slowly your output folder will be huge with the stuff that you don't want. There is also option to make preview image and not save, but we don't have this installed yet. And this is one of the custom plugins, which most of ComfyUI you will see it's custom plugins, but right now we really are in the basics. Next question. All right, good. So I would like to go to the next one. So we did now, basically, we were able to create simple workflow for text to image. We were able to create simple, very simple workflow from image to image. Okay, now let's see what will be our next step. Image to image, and just let me see that I'm not missing something. Okay, fine. This is how we're loading the image. Load image will have two outputs. One of them will be image, second one will be mask, and that's what we're going to touch in a moment. Right now we didn't use mask. Our VAE encoder, which we did encode our pixels inside of latent space using knowledge of VAE, and done. Very simple. You see. Next one. Okay, let's try the Inpaint workflow. So little disclaimer, I'm not going to use it right now, but for Inpaint you should use special Inpaint model, meaning that if you have a Dream Shaper model, there will be also a Dream Shaper Inpaint model. Why? Because when you're going to do Inpaint in Series 1 with a model which is not specifically Inpaint model, you will select the mask, you will say, give me the robot there. He will not look too well on the left and the right, and he will put the robot, but it will be not so connected to your image, while the specific Inpaint models will do it better. Or focus nodes. It's a custom suit, it's custom nodes of ComfyUI. It's not of ComfyUI, it's the custom model. And what this model is doing is operating on your clip. You remember conditions? And what it does, this model specifically trained to help you to set your conditions in the way that every model that you're using will be Inpaint model. So this specific focus nodes and focus model is just helping you not to deal with that. Okay, so this is little disclaimer, will be very much not important for us right now as we're going to do very simple Inpaint. Okay, so I will duplicate, Control and drag, and then Control Shift C. That was unexpected. Sorry, Control C, Control C, Control Shift V. Shortcuts, you will get there, don't worry. Okay, so how do we Inpaint? So right now, Doug, you said, well, I want only specific parts of the image to be changed. And I think very logically, we will just have to create a mask. We can create external mask, but right now I will just create mask directly on this image, and I will just go right click, open in mask editor. Very simple, like no brainer. Guys, what we changing? First one, just choose something simple, please.
The head.
What?
The eyes. Yeah, let's change the head itself.
Eyes.
The whole head.
Eyes was first one. I will. Okay, good. I just this morning tried something with eyes, didn't work with Salvador, but let's see. Okay, eyes. Save to the node. Okay, good. So we have very simple mask, and now what we want to do, and let me go back to my presentation. We did our masks. Now we need to say that we want to apply this mask, our latent denoise and then renoise, noise and then denoise just where the mask is there. And there is a node which called VAE encode for Inpainting. But this node actually is just few nodes together, and every compositor will immediately understand what's happening here. We have VAE encode. As we know, we're going to latent space. Here we're getting our masks and we're applying expansion to mask if we want, erode. And here we're going to set latent noise mask. We're applying the mask to our space. So all that is inside of one node here, but let's do it complicated so we will be really knowing what we're doing there. Okay, so grow mask and set latent mask. So we're going to our latent space. Then we will say, well, we will grow mask. We not necessarily will use it actually. I will put it aside. I don't want it. And then what was it? A latent mask. Please. This is little annoying thing that set latent noise mask that you really kind of like sometimes set latent noise mask. Not able to find your node. Okay, so let's not use any grow because we don't want to dilate. So what we want our samples, we want our mask, that's it. And we will bring this latent inside of the image. Okay, so now let's see what's happening. Well, I very hope that it will work. So we have a picture, and then we want to alter this picture, but just in these marked areas. What we want, which eyes, guys? Now we need to give a prompt, which eyes we want to have there.
It's blue. Change it blue.
Okay, okay, blue snake eyes, Biden eyes. I don't think he will do it, but maybe. Okay, blue snake eyes. Okay, good. Now let's have a look what's happening here. Let's leave it as it is for now, just to see. Control Enter, and are we calculating? I press Control Enter. Yeah, he's running. Let's see. Okay, good. So as you can see, it was kind of a success. What did we write there? Blue snake eyes. Okay, so it was a very, very minor success. He didn't give us blue eyes. And let's have a look on our sampler. And my first thing was denoise, how much I denoising the original image. And as I can see, it's 0.4, meaning he was keeping 60% of the image, and then he was applying it. But let's say, no, dude, we want 1. We won't go crazy. I think 1 it will be too much. But yeah, he kind of went completely crazy. So let's not go. And by the way, if it will be Inpaint model, most likely he will not go so crazy. But let's give him like a snack, 0.8. This is snake eyes. And again, this is a very good example. When the model is not Inpaint model, it will give you something, but it will not sit there in the way that you would like it to sit there. Okay, 0.5. I just want to bring it to something which will be not completely embarrassing. Okay, great. Okay, good enough. Okay, now additional things that we can do. This is a compositing area. We can apply color correction to our material before, and then we will be better. Now, I'm not going to touch that. This is not the workflow. I will just show you in the end how the real Inpaint is going to work. This is very basic. The very bad part of this workflow right now, when we're cutting this stuff out, and I will show you what I will go from Latent to back to the image, and I will make a save image, just to preview what we're feeding the model with, okay? And you will see the problem. Oh, usual thing, I forgot VAE, that's why he told me, no, dude, you cannot do it. Control Enter. Actually, he didn't show me, but he did. I, for some reason, don't see the mask applied. Okay. Let me do something different right now, and maybe I was mistaken, but it will be quite what was this? Let's apply, instead of this note, let's apply VAE and code for Inpainting. VAE and code for Inpainting, because I think he will do something else. I will get my image, I will get my VAE. Alexey, don't improvise. I told myself don't improvise, and here we go. Starting to improvise, and I will go again from latent space. I will go to decode, and from decode I will go to save image, and I will give it a VAE. Control Enter. Let's see if yeah, you see there is difference. So you see what's happening when we're applying the mask. He actually putting the gray there. Usually you don't want to have gray, you want to have actual some color there. So let's not let's try it with this Latent instead of what we did previously. And then I will go to our next example, because I'm afraid I will lose you otherwise with me rambling. Oh, look at that. It's way better. It's still not blue. He has problems with blue, huh? 0.8. Now I will try to force it. Sorry, I promised you, but I want to force it. Yes, blue eyes. Great. Again, it's broke. Okay, good. But this will be the Inpaint. Philip, yes, your question.
Yeah, just wondering. I mean, could it be that just in the in nature, blue snake eyes are less common than the
Yes,
the other ones, and then it's just not in the
absolutely.
sample base.
Absolutely. Yes, this is one of the very important stuff. If your model doesn't have it, you can just write blue eyes till next morning. You will not get your blue eyes. Absolutely, this as well. Okay, and that's one of the really things. Like you can spend like hour, but I did it in my like second day. I was trying also kind of blue eyes, but model just didn't have it. Okay, good. So this was Inpaint, but I would like to go to the next. Okay, because we kind of like we have this overview. As you can see, let me clean this a little bit. Delete. I will delete also my preview here. Yes, Doug.
Yeah, I just have a question about the Inpaint process.
Yes.
So, is there a simple way to inverse a mask? Basically, is there a node for this or something?
yes.
Let's say you first want to change robot, and then you're happy, but then you think you also want to change the background, but you want to use the same mask.
Absolutely. You have invert mask, and you will use it a lot. Yeah. Yes, you have.
Okay.
Questions regarding Inpaint? Okay, good. Let's go to next one. And the next one will be Inpaint. We're still in Inpaint here. By the way, you see, I told him the shark teeth. It was cool. And I used VAE encode for Inpainting, so it's actually did better job there. Okay, ControlNet. And here. Now let's go here. So first explanation on the ControlNets. Okay, ControlNet is again additional models, and these models are what they providing us. They're providing us with additional ability to add additional condition to our clip. Okay, so you see this is our clip, this is our prompt. Additionally, we can add ControlNet node there. What exactly ControlNet is conditioning? He's conditioning the shape. So we can say, I want this to be like that. All the TikTok videos that you saw, right? This was done with the ControlNet, and this will be the look of our ControlNet in our example in the moment. And I want just to give you overview before we building that. So we will provide our model. We'll provide our ControlNet model, which understands one specific type of ControlNet, which called Kani. What Kani is doing? Kani is basically producing lines from your image, or Kani, one of them. In order to produce these lines, you have to use node which called a preprocessor, and there are specific preprocessors for different ControlNets. Something that you can see here. This is an example. You have an image, and then you're running one of them through Kani. Second one, you're running through open pause, and that's one that you're familiar with. Next one, I'm running here through depths or segmentation, seg something. So there are many of them. You could use one that you think that works best for you, or one that actually has a license that is good enough for you to use, because I'm not so sure that you can use open pause preprocessors and ControlNet. So there is different kind of like, licensing. Back to us. What else we will have to take care of? We'll have to provide an image. We'll have to resize our image to the size of our actual material, because it will try to force our robot to be in this shape. And here I'm previewing just what I'm doing with the upscale, with the resize. Then I'm applying preprocessor. Then I'm previewing for myself how much I see actually. And then you can set threshold. And then we're feeding our ControlNet. Okay, easy peasy. Let's start from very beginning. And I will start from, I can start from this, but I will start from, because I do want to keep everything easy, Control C, I will take very basic, Control V, very basic text to image, and I will say Control Enter. I will let him calculate. Meanwhile, I will bring image. Load image. And let's bring something. I like just something from here. Let's go. Okay, so will be the image that will drive our ControlNet. Okay, as I mentioned, ControlNet will sit in our condition area. And let's try from memory. So I need to load ControlNet model. Load ControlNet model. Okay, good. Then ControlNet model, and here I will just like, you know, because he will give me what he needs. ControlNet apply, fair enough. Okay, good, conditioning and image. Okay, very good. So first I will go conditioning, then image. So this is my image, but this will be wrong to feed my image directly because it's not, and I want Kani ControlNet, sorry, I forgot. So I'll just zoom in so you will see what's happening here. Another important part, you have ControlNet for SD 1.5 and you have ControlNets for XL. And I will choose XL because my model is XL. Very important. Be prepared when you're starting with ComfyUI, a lot of red screens. I mean, error, 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 because we're missing stuff. And now, image, we need Kani as a preprocessor. Image going to Kani and image going inside of image here. So we are ready right now. We just need to put our condition inside of our sampler. Let me move it because I do like everything very linear in the positive. Let's just run it even without checking what is my threshold kind of like results there. I will put it actually here, save image, just to see what I'm getting there. And I will leave the same prompt. I will leave everything by default. We will go now back to ControlNet to see what can we tell him. Okay, first of all, I see that my lines are quite cool. And let's see if I will succeed. I kind of over succeeded here because it's really crazily did like everything I want. Now let's see where we can control it now. Okay, so let's go back to our ControlNet and we have apply ControlNet and strength is 1. You don't have to use the save image for preview. There's image preview node. No, I didn't find it, Michael. Maybe the image. I was thinking that it's
it's in the when you not in this menu.
Yeah, that's right, preview image. Okay, good. Okay, so you get preview image, but let's let's jump right now. Let's jump back to ControlNet, and here is our ControlNet. There's not so much here that you can control. You can control in a preprocessor the strength of lines. And I think this is great what we have. And we can control strength of the ControlNet. So let's just go and not go so crazy, 0.3, because I think we're kind of really overpowering right now the condition there. Okay, cool, way better. As you can see, right now we have our robot in the pose that we did define, but it's not human anymore. Now, I do understand it looks terrible, but this is basically your way now to control your stuff. You can use your ControlNet together with the image to image, which you will be able to push your image to certain direction while it's still looking the same. Of course, right now we can see that we have 2 heads. We really don't like it, so I probably will want to go change my seed, and something will go and will be different, and then slowly you will get where you want to be. Okay, boom, way better, guys. That looks, I believe we can agree that we achieved our goal, at least for this presentation, the guy in the pose that we would like him to be. And I would like to jump to the next example. Please, questions regarding ControlNet? No. Very good. Is anyone still awake? Yeah? Okay. Okay, very good. Stay awake, guys. We're almost there. 1.5 hour. It's impossible to hold. I know. Yes, make some noise. Exactly. But we will get there. Okay. So I'm catching up on my ControlNet. We're mentioning SDXL. We're mentioning there are few ControlNets there. That's how it looks like. That's, by the way, how I created the Chuck Norris here. It was very hard to push him to be there. LoRAs. Okay, next one, guys, fun one. LoRAs. I wrote it. Low rank adaptations. Again, remember LoRAs, it's fun. Okay, so what are LoRAs? LoRAs, it's small models which trained specifically to push your big model to certain direction. All right, so what does it mean? Somebody really likes anime. He will pre-train many images of anime, and then you will add your LoRa to conditioning. So your big model will produce something, then it will go through LoRa as a conditioning, and LoRa will extract from the big model or will connect to big model and will push your conditioning to be something that LoRa was trained for. Let's try it. I will go back to base again because I do want again to be very much simple. We easily can combine all of them, and I will show you example of combination of all of them. But right now, let's bring LoRa. Load LoRa. Okay, very simple. It's expecting the model, is expecting the clip, and will output clip again, and the model. Okay, I like the Cyber Mech Exosuit LoRa, and you have like thousands of them. It's very important not only for art department, not only for concept guys to go to certain concept. It's also important for a DMP, for comp, if ever we will use it, because you can decide which style you want certain object to be. Let's connect it. No brainer. Okay, LoRa here, clip, yes, clear here. We output our model, meaning that we will replace in our sampler model to model, and well, clip will go to our conditioning here. So that's how it will look like. Condition going to LoRa, going to prompt, and going to positive. Now let's make now just for fun, because robot. No, let's do it. Okay, Control Enter. Boom.
Does it have to go to negative as well or not?
No, just positive. So this LoRa will push our robot to be cyberpunk, not cyberpunk, whatever it was there. Cyber Mech Exosuit. And we can see how much it did change our picture. Everything is the same direction, so we're still there, but now we have our suit there. And LoRa, similarly to ControlNet, we can say how much we want apply of the LoRa on our image. So basically, how much LoRa will intervene with our prompt. You can mix few LoRas. You can put one LoRa after another. You can mix prompts and LoRas. We're not touching this right now, but it's like simple merges that you're doing basically. Okay, as you can see right now, we just slightly added stuff, and he looks really badass. This is LoRa. There are hundreds of LoRas out there. That's how we're using this. Questions about LoRa? Very good. Let's go to next one. So this was my example of the LoRa when I was basically preparing for this one. Okay, let's try upscales. Upscale, something that we're using. Yes, Andrea. Oh, Andrea. Hi, didn't see you.
Hey, hello.
Yeah,
sorry, Alexey. So who makes LoRa? So like, how do you make LoRa?
You can make LoRa. I tried to make LoRa. My computer kind of died on it. I tried to make LoRa. Yeah. You can make LoRa. You need to have computer which is not completely crappy. And then you will be able to create LoRa by yourself. There are tutorials. You can create LoRas also inside of ComfyUI. I didn't try to do it because it was kind of a little bit, there is a special program to do it. It's called Konya. And if you're not scared, you can do it. Okay?
Yeah, because it sounds pretty interesting. That helps it out. Yeah, awesome. Thanks.
Yeah, you're welcome. Let's try to upscale. Two things with upscale that I would like to touch. There are many workflows to upscale. I will touch two base ones. You can upscale the image, or you can upscale the latent. When you're upscaling the latent, you're upscaling inside of latent space, and you basically adding just some additional noise, but you're not going to go out of latent, upscale, and basically the result will be slightly different. And I will show you the difference. Okay, when upscaling the image, usually you're just saying, well, let's just upscale it with a certain model. That's what I will show right now. Okay, so let's upscale the image with a very, very basic way. We'll just use an upscale model that you have on internet, 4x ultra sharp, and so on. As you can see, this is the whole setup. Okay, so I will just go there. I will take this guy, Control C, and we're already like 1K here. And no, I need to save it. Save image, and then copy image, Control V. Okay, so this is our image. I will fly through this. Upscale with model. Upscale image using model. Okay, good. So what he's expecting the image, he's expecting the model, load upscale, load up. Thank you very much. And we will output image. That's it. Save image. Thank you very much. Control Enter. He's calculating. He doesn't like that this one is flying around. I will just delete it. But this is pretty much no-brainer. Here we go. We have 4 times upscale, and basically for hard surface is just awesome. Okay, this is really, really good. So this is one type of upscales. But I will talk about now different type of upscale. I will keep it here. Wait a second. I'm starting to rush. It's bad. I will not rush. I will talk about the second type of upscale, how we upscale inside of the latent space. Okay, let me duplicate again the very basic setup. Control C, Control V. And let's see where we're going to upscale. And this is one of the very, very base things of ComfyUI, or anyone who's producing actually quality images, that you're never just going through one sampler. You're going to go through few samplers in order to get your results. So I will just duplicate my sampler, and I will see what we have here. We're getting out with the latent, meaning exactly as we're coming in with a certain latent, we're getting out with a certain latent. And I will go with this latent from one sampler to another. I will reconnect my model, and I will reconnect my negative prompt as well, just for fun. And negative, not positive. And I will give different positive prompt. Okay, this will be maybe not crazily important, but it will be. I will just say high quality. Right now I'm improvising. Okay, high quality. Okay, so this will be the sampler. Out of my sampler, I will go inside of the VAE and to the picture. So what's happening between this guy and this guy? And this is the workflow that used a lot. The first step will be to produce image with not too many steps to get some general idea how it will look like. And usually it will be 10 steps. But then you're upscaling your image and calculating more steps in the next KSampler. So I will say upscale latent by certain amount, by 1.5 for example, and I will put this upscale latent by between these two KSamplers. 1.5 interpolation, I will choose by cubic. Let's see. And they both have the same seed. You probably don't want to have the same seed because it's called burn itself, because it will try extract the same details again. And instead of doing that, I will just go different seed a little bit. And also what you probably want to adjust is the noise value. You don't want to denoise your image completely, because as you can expect, if you're denoising this a lot, you will get completely different picture. You want to denoise it slightly, 1.2 for example, and then it will be upscaled, and then it will bring back the new details in upscaled image. Usually, okay, you see red, I forgot to connect my clip, and I will connect my clip. Usually, you will have to play quite a lot. Maybe it will be broken right now for me, the upscale. I very hope it will be not, because this is the last thing that I would like to show from the workflows. It will be kind of like fail in the end, and I would like not to have it. But let's see. So he went to first sample. Now here's then he did upscale the latent space, and then he gave all this upscaled noise back, and we just trying to improve the quality of our image. Okay, as you can see, I did fail, and right now for me it will be kind of like back and forth to understand, okay, where is my mistake? And I can say, well, maybe my conditioning is wrong. Okay, and I'm always doing this. Maybe I want to go 1.5 with the noise, and let me keep it like that. I frequently falling inside of this, and then I'm like, ah, yes, of course, I forgot something like 1 or something like 2. Let's see if I will not get of this, then it will be fail. I don't want to waste more time on that, because eventually I will get it or you will get there. Okay, so now it looks already a little bit better. I don't think it's way, oh yeah, it is way better. So my denoise level was too low, probably. Or my CFG, what I did change? Yeah, I did change the noise. Or maybe my prompt was wrong. So I didn't have to replace my prompt. Questions about the upscaling? Okay, good. Now, let's see where I'm. I very hope I'm done with showing new stuff, because my brain is boiling. Upscale latent. This, for example, was example of me upscaling the latent, and you can see how many details he did add on top, which is quite cool. Oh no, IP adapters. Okay, the last one, guys, fun one. Okay, so additional thing to move our footage to certain direction will be IP adapters. Please allow me not to create a workflow. Allow me just to show you how it works, and then I will show you the workflow that I already used. IP adapter is operating on the model, and the IP adapter is telling which style of a picture you want to produce. So in this case, and of course it's using its own IP adapter models, which you need to be really specific with, and you're applying this on the model level. In this case, I found this picture from our time of Captain Marvel, and I did apply it on our robot, and that was the result. That's how robot came in when I told him, I want you to be more like this, and that's what came out. And this is very, very powerful, and I specifically leaving last 10 minutes to show you actual something that more resembling how it actually will work, and show you the actual implementation in our tests right now. Okay, and that will be this. So first of all, I will show you some play blast of the test that we had. So basically what I tried, and you guys probably will be able to read what's happening there. I will just go from left to right, and I do expect that you will know what's happening. Now, first of all, I'm using stumps. Ta-da! But basically, just for you to just very understand that every time when you see that something is not connected, it's probably connected to the base stump, very base model. So I have my model here. I have some conditioning, futuristic prison compound. Okay, I also have here additional condition, we don't care. And this is, what is this? My original image that I'm going to feed. Okay, that's how image looks like. I'm going to my ControlNet, and it will give me the shape of the image. And here is IP adapter. It's how I want my prison to look like. Now, guys, extremely... Yes?
Yes.
Okay, Gilberto, you have echo. Can you turn off, please? Sorry. Yeah. So this is IP adapter, and what I found extremely essential, you really want to feed the look with very good IP adapter, your black point, your white point, your intensity of shadows and the sun. It will be very important to produce final result. So this is my IP adapter. I am upscaling it to certain resolution I want. I'm applying IP adapter, and I'm going inside of my sampler. And here I have comparison of what I had to what I have right now. Okay, so basically this is, I put the strength of my ControlNet very high, so it really will try to go and get as much as possible. And then the next step, I'm upscaling my prison. So I'm going to my second KSampler and giving him more samples. And if I will compare what I had in the beginning and what I have now, I do have better defined objects in certain areas, and I can play with this way more, but right now it's just examples. And the final result is basically this. Okay, and right now what I can do, for example, if I want to experiment with the look, I can go here and let's see, and I can denoise, and instead of 0.3 I will denoise 0.7, meaning if I'm not mistaken, he's loading right now everything. My final result here will be way, way different from what I entered in very, very beginning. I will let it calculate, but I will go to the next example, which is Inpaint, while it's calculating. Okay, so this is one of the images that we have. And basically, this is the Inpaint process that we went through, just a little bit on the steroids. And that's the result that we're getting. There's zero manual Inpaint, okay? And this is very, very impressive as a base later to bring this to comp, to bring this to Photoshop and keep going and improving and fixing stuff, okay? Now, let's have a look on the tree itself, okay? So, guys, you already can read it. You can read it, I believe. If you can't read it, then I failed miserably. We have a model that we're loading. This model will give us everything we need. Model clip VAE. We have an image and we have a mask. This time I did load external mask. I converted it to mask and it's used later. And then you remember our gray eyes? That was bad. We can Inpaint using a model. Philip?
Yeah, I'm just wondering, the mask you input, the black and white image, was that like a very precise, time-consuming mask, or just, you know...
very rough and blurry, which is important.
Okay.
So what I did here, instead of pre-processing and making whole gray, I pre-processed with a model called Big Llama, and this model somehow filled in our holes, but it gave me very nice structure there already to start with, and it has a seed. So it took me time because it was giving me different kind of like benches that I don't like. And then after that, I went inside of already the focus in Paint and an additional round of the Inpainting, which is happening with the KSampler. And that's what I've got here. Then I did upscale it one more time just to get better details. And in the end, final upscale to bring it to 4K resolution. Okay, so this is the very practical usage that can be packed, which is packed inside of one workflow. So we theoretically, practically can connect to Nuke, we can connect to Photoshop, to Krita, to just give it something and it will spit you automatically whatever you want if your workflow is good enough. Let's see what we did here. Okay, as you can see, I denoised it a lot and then we lost all connection to our prison. But if you're going 2.5, 2.6, you're starting to get very cool. Different seed, very good, different stuff. So you're starting to play with that. This example, Alien. This is not an example. I was just playing around. I just thought, I want Wesley Snipes, give me the direction, and then I want to create an alien. And then I want just in this area to exchange his teeth. And exchange, and then I want to upscale it so it will look a different way, and so on and so on. But this is really not important. Back to our workshop and done. Questions, if you have questions. Otherwise, I think that's way more than enough for one day. Okay. Closing statement probably I didn't prepare, but anyway, generally I'm saving this video. It will be as always accessible for you guys. Zoe, sorry, my daughter is at home. Tür zu bitte. Ganz leise. Okay, sorry. So what I would recommend, and specifically I'm talking to compositors at Trickster, guys, we have it for educational purposes right now in company. Please touch it, please play with this, because the more people will touch that, the more people will touch it, the more we kind of have the confidence that we actually can use it on certain moment. And it is very, very scary, and I was very scared to enter it. Same with the deepfakes, where like 2 years ago, oh my God, this, you're entering, it's a tool, you can use it, eventually you will be able to use it without feeling bad towards certain direction. And I'm talking about our chat group. So I would recommend you to try to play with these things. Yes, questions, hands.
I assume this works for image sequences.
Okay, good. Image sequences, I didn't touch. It is something that by myself, I did not arrive there. And the reason is that it does not work for image sequences so well. There's a lot of examples of basically GIFs, which looks very weird. And for me, as compositor, image sequences are not as important currently because so far there's nothing which is providing very stable, very good patches in Stable Diffusion, and that's why I prefer to push stuff which I really want to use right now and can use, and I will wait maybe for better splats implementations or Sora or something else, and then we'll talk about that. Right now I would not touch movement. Doug?
Yeah, I was just wondering about, so this is basically ComfyUI.
Yes.
And is there a specific reason why ComfyUI is really good? I mean, there must be other variants of this, and I'm just kind of curious about if this has a really big user group and is good for particular things and others are good for other things, that kind of stuff.
The answer of dilettante, which I am, so I don't have much experience. I did play with the easy diffusion, which is the interface in your basically Chrome as well. The very big difference with the ComfyUI and everything I saw else, if you're working in the Midjourney, if you're working in Automating 11, you're going to produce one image, you're going to copy it, you're going to next page, produce another one. You're going to copy or going to next page, producing next one. Now try to come back there. Maybe you can, but node-based approach is easy. You always can come back. You have a good overview. It's basically same thing like you will say, well, After Effects or Nuke, okay?
Yeah,
or very similar.
So that means that this is very nice in the sense it's very controllable.
It's extremely controllable. It's extremely customizable. So
yeah,
you can enter everything everywhere in every place, and people able to create on other applications mind-blowing stuff, which is fine, but I would like to have full control, and I think this one gives the best for my taste. Yeah.
Thanks.
Salvador?
I'm wondering about the bit depth of the images that all of these we are outputting.
Currently, and the very base, it's 8-bit, and it's PNGs and it's JPEGs. It is possible, from my knowledge, that smart people can convert it to TIFF and to EXR. And the cool thing with Comfy that it's very accessible. There is a API, and like I don't know, it's written in Python or not, but there are already EXR for ComfyUI. Basically, I think Magno wrote one or was using one. Magno Borno, which just released the connection of ComfyUI with Nuke. So as I know, there is no stoppage to make it EXRs, as I know. I may be mistaken. Usually model internally are 32-bit, as Michael is mentioning. As you can see, yeah. So I was kind of like not wrong with that. So yes, you can go, and we can go kind of like and quite professionally there. More questions? Okay, then I thank you for being here. Again, I'm going to save that. I'm going to put this video and in our conference, and well, I hope you will be able to do something with that, and maybe not in ComfyUI, another application, but a base knowledge hopefully will be there already. Thank you very much, everyone.
Thank you, Alexey.
Thank you.
Thank you.